Start now. Excellent. Oh, I'm mute. Just made it in time. Excellent. Hello, everyone. Thank you for coming this evening, and we'll have a lot of people online as well, so try and keep the language clean when you can't get to the right URL. If you do encounter any problems, there's plenty of people around you who will be happy to help. So the guys at the back, Wally here doing the media, other helpers over there, people will be prepared to help you if you're struggling at all. Just some admin and housekeeping. Fire escapes. So where you came in by the lifts, that's where the fire escapes are. If for any reason you hear a fire alarm, it's real. Probably not a shock that we wouldn't schedule a test at 7 p.m. on a Thursday night, but if you see it, it's real. Fire marshals will accompany you outside. Bathrooms are in the same place, just by the lifts, so if you need to go, just grab someone, and one of the helpers will help you because it's swipe card access to get back in. There'll be food and extras after, and people will welcome the chat if there's anything that didn't make sense. If you want to discuss some of the concepts further, please feel free. The guys do it as a labour of love. They want to talk about it, right? Just on the topic of the playground generally, we're very big believers in hands-on. I think it's really good for us, and we're very pleased about the fact that the number of people who are involved and engaged online. We've hit a much bigger audience nowadays. We're up in the hundreds a lot of the time, but we do still really enjoy you guys actually coming and doing it in person. It means a lot to the speakers. You're incredibly lucky tonight. You've got Anthony talking on a very topical subject, you know, zero trust. Basically, how do we not get in the way of ourselves when we're trying to make for a secure environment while still being able to actually deliver work. I think it's tonight authorization. Authorization, right? So you know that double header, authentication and authorization. For me, authorization is the much more interesting aspect. I'm sure Anthony will make it so for all of you, right? Yeah, I'll set the bar high. I guess the last thing is that for us, we really enjoy letting people play with new technologies that you might not always get a chance to play with, and doing it with other people. Everyone here, like I say, is a volunteer. They've done it in their own time. We sponsor it, but that's it. We just provide a building and a place where they can do it. So they really want to talk about it. They really want to make it a success. If there's anything you want to discuss after, they're going to love discussing it. And if there's any feedback you've got, please let us know. But otherwise, hope you have a really good evening. Hope you learn something. Hope you enjoy it. And if you're confused at any point, don't muddle along. Just put your hand up and someone will help. Okay? Great stuff.
All right. Right. Yeah. Good evening, everyone. So I've got a few slides to present, really. It's just to give us a taste of what we are actually going to go through today. So my slides is like a preamble, get you started, and then we deep dive into some hands-on solutions, really. So what are we talking about? We're talking about zero trust. I don't know if anyone has any experience around zero trust and exactly what it is, really. So just a brief history of what zero trust is. So primitively, in the past, what you have is when a developer develops an application, then you'd have your security actually embedded in code. So in those days, we used to have security and group IDs and permissions, actually role-based access control and all that stuff, either part of an SDK or part of a developer's client library. So that actually was part of the same solution. But what zero trust does is it allows you as a developer or an IT guy to actually do your stuff, check in your code, build your solution, but hands off the access control, in this case, access control or identity for your workloads to something else. So for zero trust, we've got two solutions that actually do this stuff. One is the identity, and the other one is authorization. So you call it Auth-N, which is authentication, and Auth-Z. So I'm just going to run through the agenda for today. Why zero trust? Explain that. Again, one of the advantages of zero trust is it allows you to control access to whatever, whether it be resources or access for ID tokens or user access to any resources in your environment. So you can control it. And then the key word is you can control it dynamically, really. So you don't actually need to sit in there or wait on a IT guy to go set up access control for you or group policies and all that stuff. You can actually write that behind the scene and then allow some open source engine to do all that work for you. So we're just going to go through the architecture and then some strategy and why we do zero trust with some ingress here. We've got service mesh, Istio, and all that stuff. So just going to run through this quickly because we've got a few things to cover. And then the tenets of zero trust is policy definition, access to resources, secure communication, data collection and audit, authentication and authorization enforcement, and then you've got monitoring, PCI DSS and all that stuff. Security layer on top of it as well. But so what we are going to focus today is policy definition number 4, and then part of number 6 actually. So number 6 is authorization enforcement. So in order to get authorization, you need to write a policy to do that bit of work for you. So in terms of architecture, here, sorry. Make it bigger? Is it? Yeah, okay. Thank you. I'm just gonna get that animation. Yeah, okay. All right, thanks. Yeah. All right, so, yeah. So in terms of that, just going back to our definition for that. So yeah, so we're looking at the architecture here. So just explain in terms of architecture. So normally you would have in your clustered environment, especially cloud native solution, you've got your cloud environment, and then you've got your service mesh, which is an ingress controller. An ingress controller has sidecars. In this case, an Envoy proxy. We're using something called Istio. I don't know if you've ever used Istio. And why Istio? Istio has first-class integration with Envoy. And Envoy as well is a service mesh or service proxy that allows you to tunnel into your Kubernetes pods, get information from pods, and then provide you pod-to-pod access control. So you can actually restrict access based on from one namespace or from one pod to another using TLS or permissive text option. So here we just define how we set up the cluster. In this case, we've got a control plane, which is where we have the Istio, the service mesh configuration is defined there. And then we have a proxy. So the proxy is automatically injected into your Kubernetes deployment using admission controllers. So maybe you want to automatically do that stuff. You don't need to write every single code. You just do some labels. And once you do those labels, the proxy will be automatically injected into your pod. We'll show you how that works. So running through, this is just OPA engine. So OPA provides the policy engine at the back. And then you've got your service coming through your ingress. Your service can be your application that is deployed in your cluster or in your namespace. And then what OPA does is OPA tunnels through the Envoy proxy and then allows you to get into your service or into your deployment. So you can also have policy-defined engine. You can write those policies in rego language. So we're going to go through that as well. And finally, we're looking at the gateway. So some of you may be aware of OPA Gatekeeper. Again, Gatekeeper provides one of the features of policy definition. You've got 2 levels of policy definition. We've got the ABAC, which is attribute-based access control, and then we've got role-based access control. Mostly, Gatekeeper does for you attribute-based access control and using admission controllers. So, and then finally, we're looking at rego. Rego is a policy definition. It's a language that allows you to write how you want your policy to be defined, and then you can check that into a code or into a repository somewhere, and your definition will become live. Once it becomes live, it becomes dynamic as well, and then your policy engine will evaluate that definition and finally be able to allow or deny access. Again, we're going to deal with role-based access control, as I explained that to you earlier on. So, and finally, we're going to do a lot of hands-on using the rego playground. And if you can join me, I'll just go into the next slides and so just give you what we need to. So let's go there. So right, so I'm sure you have access to the labs. If you can get onto the labs, top ID, yeah,
to which Wi-Fi should we connect?
yeah. Someone can help you there.
To which Wi-Fi should we?
So yeah, so if you are on the meetup group, you've got lab.devops.playground.org, and then you just sign up with your meetup ID or meetup username. So in this case, I'm going to sign in with my one. Okay. So what that does for you is it provides for you some of these things that are an environment for yourself to use. We've got a playground, which is where we'd write some of our codes. We got an IDE as well. And then finally, we've got a... Okay. Yeah. Just let me know if you have any problems with getting access to. Okay. Anyone having any problems getting on? Okay. Yeah, so we give them some time, right? I mean, so far while they're getting on, do you have any questions around what we just explained regarding OPA, policy definition, and anything else? Any questions around there? None? Okay. Cool. Yeah, it sounds a little bit strange or difficult to pick up, but as we do the hands-on experience, you'll get more familiar with it. So, right, so I'm just gonna, I mean, if you have access, if you have issues connecting, then I'm sure the guys can help you. So let's just continue. So, right, so what we're going to do now is, I think, yeah, I think it is. If you go to lab, the DevOps Playground, it's available on the Meetup as well.
Sorry, it's not linked in the Meetup, I'm afraid. So you just need to type lab.DevOps Playground as a one word. It is linked in the YouTube. .org, exactly.
All right, okay.
My username and it's still rejecting it.
Oh, that's your email address. It's just your username.
Okay, I did that the
So
same thing
that
as
will
well.
be Meetup username, so whatever. So if you
Don't
go,
need the email address?
we can't get your email address. So if you do view profile,
My name.
that will be, yeah.
Okay, I'll put it down.
Sorry, this is the only way we can get anything about you from Meetup. I think you should
That's
be
it.
able to scroll down. There we go. I'll find it.
This is how you do
So for the first step, we need terminal ID or PA playground with link.
Yeah, so we're actually going to go through the GitHub. That's the last one, the README. Then we go through the README and, yeah.
Space, yeah.
So the essence of the README is the language basic itself. We just need to get people familiar with the language itself.
Yes, thank you very much.
Can everyone else details on that when you enter your Meetup page?
If you remember. If you don't remember,
Okay.
OPA extension as well.
Just checking if everyone is on the README page.
This one, no idea.
All right. Anyone having any issues? No? Okay. All right, great. So let's just go on. So, right, so this is just explaining how you can get onto your IDE and your terminal environment as well. So if you look through the README, what we're going to do is we're going to go into the rego getting started. We're actually on step 3. And then step 3, you've got a link to getting started there. So if you click on or open that link on a new tab, just to make sure.
On step 3.
Yeah, step 3. There's a link there called this one here, getting started. Okay, so if you open the getting started, what it does is just a quick brief explanation about rego. So rego is actually inspired by a declarative language called data log. So it's the data log extends the rego policy originally. What it does is an old language that you use to declare control in the sense that you query the language, you've got functionalities in there that allow you to create rules, and then within those rules, the rules will evaluate the policy and then allow or deny access. So it's an old language if you have ever noticed or work with data log. But yeah, so, and then rego as well it uses a bit of data log in the decision making, and then it extends the Golang as well. So it's got a bit of mixture of those two. So coming down to the primitive, rego also uses the same primitive as any other language: string, numbers, booleans, structured types, and then REST operations and everything else that it does. So what we're going to do then now is we're going to click on the link. If you look at that after the REST operations and policies, we're just going to click on this link here, and it's going to take us to the rego playground. So if you open that link, perhaps in a new tab as well. Right. So it takes us to this playground. So here's where we're going to start, doing some little hands-on. Okay. Right. Okay, cool. So what we've done is, in terms of how rego works, you define a package. So a package is like a namespace, right? So in any language, you define the namespace, and then you do some import. You import in some plugins or whatever it is from your SDK. So it's got a built-in SDKs where you can import some values of variable information and strings types and everything else that you use to write your query. So in this case, what you're doing is, sorry.
I was wondering, like, if you could zoom in, because people online are in here as well.
Oh, okay. Zoom in here. Okay. Thank you. Let's just try to. Is that good enough? Yeah. Okay. All right, good. So, right. So what we're doing now is just going through. We've gone through a lot of stuff because it's a big language, so we can't actually exhaust everything. But we're just going to take the basics really, and the basics is it's actually decision logs. So it takes evaluates an and or a logical and or logical or. So you write a query or a function, and then that query, one returns for you a true, and the other one returns for you a false. And then the policy engine will decide, well, if these values you've defined is true, then I will allow access to my my resource or objects that are defined. And if it is false, then I will deny access. Just that sort of logical reasoning, if you like. So what we've done is, like I said, import the feature, the keywords. This is like a new advanced functionalities in rego that you import what you want to write, or import the plugins that define some values that you would actually want to use in your policy definition. And then in all policies, the first thing you do is you define everything to say deny all. If you're actually into infrastructure as code, everything you do is you deny access, and then you begin to allow granular access based on that. So his access is not imperative, but access becomes declarative, right? So you kind of declare what you want, and then your policy becomes live in that case. So in this case, what we've done is we're declaring a couple of rules. So everything there, when your rule, your function defines your defined functions, when it actually evaluates to true, it becomes a rule. When it evaluates to false, that's also another rule. So we're just going to look at some of these rules. So like here, what we're doing is we're actually defining a default value as false. So what it means is whenever you run something and that allow underscore hello will always be false. So anytime you run that engine, you will deny access to that policy. But what you could do then is you then write a policy to say, I want to negate my allow rule, and that way I want to make it true based on certain conditions that are true as well. So then that will override your default false, okay? So here we're just going through a couple of these, right? So the playground is good because it allows you to do a bit of hands-on, really, rather than just explaining it. So what we're doing first is we're actually looking at defining the Hello World application. So we've got an input on this side. So an input is a JSON file or a JSON object that you can actually inject into your policy. And then we've got data. So you think about it this way. So if you're actually writing applications in Kubernetes, your input will be your request call. So your HTTP requests and attributes and everything becomes your input, where your policy engine would then look at a defined data source, which is, in this case, your data JSON. So what it does is if there is an attribute like in the header of that request, it can then evaluate that value in the header with some values that you've defined in your data JSON file and say, well, if this matches, then I will allow. So you don't actually need to do anything to your pod. Your pod is running seamlessly, but what you're taking from the pod is the request coming in from Kubernetes. In this case, it will be a HTTP call or whatever call that it is. So that's the basic logic of what you do with this. It can be, again, in other definitions, right? It can be any other resources, as long as you can determinate into the input of that resource, you can then define some other values that you can use to evaluate it. So if we can try something out now, so let's just please highlight, if you want to highlight this hello if input a message. So what it's doing now is it's actually telling us that there is an input that we've defined. This input, as I say, it can come in from your request. And then the message is defined as a JSON type. And then what we're doing is we want to see what will happen if the value in this message object, it can be anything, is directly equal to the value that we've defined. So in this case, what you just do is evaluate. If you click on evaluate, and then actually, hello world message, quick call, and then that's it. Yeah, so what you do is we want to do allow hello. So here, originally hello is false in this case, right? So if you define that. So at the end of the day, if you highlight hello, you'll find that hello has turned into true. And the reason why hello is true here is because the value of the definition of hello is now hello if input the message is equal to world. And we know that input the message is world here. So that actually has negated. So you can look at an object like a tag. Say you have a metadata, and that metadata can be your Kubernetes container tag. And then you want to only make sure that the value in that tag is what you want to evaluate against. So if you've got the value there, you can have that input information, and then it will actually match that. If that value is true, it will always allow it. So if something else happens and you deploy an application that doesn't have the exact matching tag, it will deny it access. So you're actually not doing anything to your pod, but you have defined a rule that will deny access to anyone deploying anything into your Kubernetes cluster. So this is just a basic hello world. So we can also look at the data in this case, right? We're also doing data, and we've got, if you look at the way we define data, the greetings here, we've got a greetings information. And again, this is a JSON type. It can be a JSON object or a set or even an array, right? Depends on whatever you define that to be. So now if you go back to your, like I said, if you go back to your playground README file, so we're going to do something interesting. We're going to copy two values here. So if you copy allow world if, or we're on step 6, right? So if you copy those two values there, and then you copy that into your clipboard, and then come back to your playground, right? And then you drop that in here, okay? So we're defining something else, right? In this case, we want to see how the rule actually works itself, okay? So now, we haven't defined anything unusual, but we know that allow world. So we've got a bunch of allow. So here is, we have, like I said, you define first allow, and then allow world is false here, okay? But now what we're doing is we want to also negate allow world. So we got a world as a string. So you can actually do a string matching. So we've got to allow here and say, if this is not equal to world, okay, then it will, what do we get out of it? So if you highlight that, and then if you evaluate that policy, you'll get a false, okay? Because in this case, we're saying that world, we're just comparing two string comparison, right? And then in the other side, if you also try to do a match and evaluate that value again, you get a true. So you can, define how you want your policy to run or what you want your policy to do based on all those values that you can pass in. Again, it can be variable values of type, let's say type string or type integer or Boolean, but the end result is you either get it true or false. So we are going to, any questions so far? This is quite basic, but we're going to go into a little bit of stuff now. So on step 7, now, and this is going to be interesting as well here on step 7. So if you copy step 7, and then you drop it into your policy playground again. So now in step 7, what we've done is, like here we have greetings as defined as false. So what you can actually write to true, okay? In this case, we're saying rather than allow or wait for the value to be returned, you can be a little bit imperative in your definition and declare that you want this value to return true at any time. So in this case, what we're doing is we're creating the greetings. Again, like I explained here, you've got variable values. You can define the variable values here. And once you define a value that returns a true or false, it becomes a rule. So that becomes the policy rule itself, the policy engine. So what we've done is here, we've looked at input or message, okay? And then we're now going to get the value from data.greeting. So you've got an input and you've got your data. So we want to match two types of values there. And if anyone can tell me what you expect to get as answer from greeting. If anyone trying this out, what would you get? If you highlight greeting, all right? Just highlight greeting that way. What do you think you'll get, true or false? If you evaluate it, once you highlight it, you click on evaluate. What do you think you get? Sorry? False. Why false?
Because the input.message does not match.
Line 54 doesn't match.
Yeah, so line 54 doesn't match. So definitely you get a false there. So if you evaluate that, you get a false, okay? And then in order to change that, so this is your tag now. Just assume this is a tag that doesn't match that value. You definitely get a false with it. It will deny access to that. And the only way you can do a change on that one is just to, to change it to the right value, and you get a true. So that's these are basic steps, but now we want to do something interesting as well. So now we're going to do the logical value, evaluation logical and logical OR. So let's take, if you copy the same allow new world again and copy it and paste back. So now we know that we've got the same value twice, but in this case, one is true and one is false. Okay? So if you evaluate this, what do you think you get? Anyone?
Should be false.
Sorry? False? Okay. Why do you think it's false?
Because the last evaluation is false.
Right. But it's actually going to give you a true.
Oh.
Yeah, so if you do this, evaluate that. And if you go to allow new world is true. And the reason is, in the policy definition, we've got this thing called a logical OR and a logical AND. So it can be, obviously if you've done logic gates or write programs against that. So when you have the same rule named twice, okay, then it will actually compare them. As long as one value is true, then it will give you a true. If both at false, it will give you false. But once one value is true, it will give you a true. Now the same goes for if you write this the other way around. Let's say, in this case, we'll create something different. Let me just use, because we wanted to test out a couple of definitions, right? So let's take up this one here, allow world, not the down one. So we know allow world here is, if you evaluate it, this should give us false, isn't it? Right. So let's turn it into true. Okay, so we turn this guy into true. And then if you evaluate it, you should get a true. And then we do something else with it as well. Then we do this. If you just type in, as I type, world, again, the same value you had before is not equal to, again, world. All right. What do you think this would be? Anyone? True or false? How many trues and how many false? Oh, you're not sure? Who can boldly tell me the answer? You? Sorry?
False,
False. Why false?
because the policy is working with and
Yeah.
derivation.
Exactly. So when you got a true and false within the same definition, then the policy is doing a logical and. And once the logical and, it will actually look at logical and usually takes the deny rule, isn't it? It takes a false as its default. So if you try that aloud now, you get that. Just actually do. Just evaluate everything. Allow world.
Line 46 is word, not word.
Sorry?
Line
46.
Oh, yeah.
Yeah, that's
Yeah. So that's false. So that's how the policy works in its own entirety. Now I'm just going to do something more interesting. This is, seem a little bit basic, but it is more than that, right? But the point is, if you understand that you can write to logical and or logical or, then you actually can define the true or false. So you've got the power to define what is true and what is false, and that makes it more declarative in its own form. Do you know what I mean? So we're going to do a little bit more than what we're doing now. So in this case, we are going to look at a little bit more robust solution. This was in the, this will be sent out in the repositories. But in order to enhance our timing, we just want to go through this a little bit and then I explain it and then we'll do a demo of exactly what we want to do within this session. So here what we're doing is we're defining an input, okay? In this input, we've got a user called Alice, and then these are the values this user has. So it can be something you're getting from your Active Directory or your role-based, whatever, OIDC or Okta, whatever that you define, or even from your JWT token where you get the values from tokens information. So here we're defining a user that this user has these attributes. And all of these attributes, we want to use the attributes to compare to something that we have defined, all right? So in this case, what you're doing is you're looking at this data, and then in the data, just looking at it, you've got Alice now is an admin in this case, and then Bob is just an employee and billing. And then we got Eve, who is just a customer. And then for each of them, you're defining the roles that you want to grant them, right? So grant roles, customer, and then you define a couple of logical information that can be associated with a customer role. We also have an employee role. Again, these are all logical information that you can also define, and then billing as well. So what this policy is doing here is we're actually injecting a couple of role-based access control. We define, as I said, we define your package, app.rback. You can call it anything you want, as long as you can redefine it the next time you want to use it. In this case, we're importing some values I explained to you from the SDKs. You can actually import all of these, which are plugins that you use to define your rules and definitions. So default, always default allow is false, all right? And then you're only allowing if a user has, it returns true. So you're defining allow if user admin is true, and then you need to go in and write the definition for user admin. So again, like in this case, you've got allow is this and allow. So you can write multiple allows. And then what OPA will do is it will evaluate all your allows, and then based on the definitions in the allow, will allow or deny those access. So in this case, we're saying we're looping through. So there are some variable values that you can use or keywords like sum. Sum is an iteration. So you're saying in this value, in the user is granted, I want to grant it. So this is just a key for an iteration. So I want to get the grant, and then I want to loop in there. And so whatever the value I get from grant is, so let's take, for example, user is granted. So user is granted is a functionality, a rule that we've defined here that has a contains keyword. So it says that user. So when you evaluate this value, so take for instance, you're doing data.user.roles. Data.user.roles here is an array or a set. So you're actually passing in an input. So you pass an input from the input value, and then you use that input to only get the value from your data.user, okay? And then that will just give you a list of the values. So for example, in this case, we're actually looping through everything we have in data.user_roles. So if you go back to here, so this is what we have here, right? So, and then the input.user is Alice. Okay, so we actually want to filter this value to only get us the value for Alice, right? So if you do that, and then eventually what you do is Alice will be returned for you all the values under Alice, and then you can, iterate through them, and eventually you've got two grants. So in this case, you got some grant and some role. So as I say, as long as you have the same number of any new line, okay, of definition, you always get an AND. So this, as long as this is true and this is true, you get a true. Okay, so this value is true, and then the data.roles, again, you're passing in the role information that you actually define from here. So you loop through this one, you get the role that Alice belongs to, and then you use that role, okay, and you also check that role and filter that role based on the role of grants. So you're actually doing in iteration in an array, you're doing a jagged array or some sort of looping. You're doing two sort of sets of loops, right? It can be a multi-dimensional array or some sort of jagged array, right? So what it does is it just loops through that, and then using the value from your resources and the value that you define from your data.definition, and then you can do that to match and return true or false. Eventually, when you return true or false, then that rule will be allowed or denied. So in this case, a user called Alice will have access or will not have access. So now this is just, I don't really expect you to, because this is not in the list, but what I'm trying to do is just go through some other functionalities with you so you can see how you can define different attributes for this particular use case. So now what we do is we're going to go back into our, in step 7, again, we have defined a couple of things there as well. Let me see if we need to do step 7. Yeah, so step 7 here, yeah, this is just the one we defined now in step 7. So that's fine. Then step 8, let's go in there. So, right. So step 8, if you click on step 8, this is what we're going to use for our demo today. So what this is about is we're going to deploy an application called a book info. So that book info application is actually a pod. So once that pod runs, we'll deploy the pod, and after that, we'll be able to check and see if we do have access or not, okay? So again, this is just going to be, it takes in a username and password. So what he's doing here is, let me just explain it to you. We're doing an authorization. You're using a basic value, okay? And then what we do is if we decrypt this, you'll see that we get a user called Alice, and then we get a password. So you can use username and password as part of your definition, right? So let's just run through quickly, and then we can then use, so this is what we're going to use, just explaining it to you. We've got some, not this one. Yeah, we're going to use this one. So in this case, we've got 2 roles, right? We've got admin and a guest. So Alice is a member of guest, and Bob is an admin. So in this case, what Bob is doing is, Bob has access to this product page, and then Alice, who is a guest, only have access to product page, and Bob will have access to product page and the API endpoint. So, this is just what we're going to use. So in order to meet up time, I will say, let us get on to the playground again. And then on your lab, what we're going to do on the lab is, if you go back to your lab, so if you log into your environment, right? If you go back here, so in this case, this is your environment. If you click on that, you will get your environment name. Okay, so I'm getting, so you get your terminal here. Mine is coming up as Premium Panda, right? So you just copy the name of your terminal, or you click on this, and then it opens your terminal for you. So you get into your terminal, obviously you get your username and password that you have. So I'm just going to log in there, right? So if you can, okay. Isn't my password changed, maybe? Let me see if my password, oh, dash, actually, okay. So I'm using 0-trust. Right. So I've got access to my environment now. So can you all, if you've got access to it, just log in to the terminal. Are you on the terminal? Okay, thank you. So what we're doing is we're just going to deploy a couple of things now, and then we'll see how that policy that I showed you earlier on. Sorry. Oh, zoom in other side. Is it better? Right. Okay, cool. So, if you logged in onto your terminal, all right, again, what we're doing, we've actually built some infrastructure ready for you. So if you do a command kubectl, I don't know if you can, yeah, get pods, just to give you an idea of what is running at the back there. Just these three commands, kubectl, get pods, right? If you enter, you'll find we've got an OPA engine. Okay, we've got an OPA engine running. So this is the policy engine itself. So we're going to so what this is going to do is we're going to define and deploy some application, and then we'll wire the application to OPA. And then after we wire the application to OPA, we then use a policy that we've written to allow or deny access control based on user Alice or user Bob. Okay. So what we do, if you go back to your, just close this one, don't need to leave this. So yeah, so if you go to step 10, okay, step 10, just so we get, if you copy that to clipboard, everything on step 10, you got a booking for application, we want to deploy that quickly. Anyone having issues yet? Okay. So if you just do that and paste, if you've got any problems, they can help you. So it's on step 10. We just copied the information we've got on step 10 here. So we're going to deploy step 10 and step 11. And then we want to see pods running. And then we want to wire that to OPA, okay? So if you do that, and just click on enter, it's going to deploy a booking for. This can be any application with API endpoints, right? So we've done that. And then step 11 as well, we are going to deploy step 11. Step 11 is a gateway. Because we're using Istio, we've got a service mesh running behind there. And then, as I say, we explained earlier on, Istio have first-class integration with Envoy proxy. You know the diagram I showed earlier on where you have your proxy and then your OPA as well. So now we're deploying the gateway. The gateway creates a tunnel between your request coming in into your proxy. So if you deploy, if you copy step 10, again, the installing booking for ingress, this one here, the ingress one here, right? Just make sure you're doing that one. And then paste it again. Okay, so what we've done now, if you just highlight again and run your kubectl get pods, which we did earlier on, we'll find a couple of things have been deployed for us. We've got some bunch of applications that are currently running, and we have OPA engine running, and as well as a few other ratings, product page, and everything else. So now we almost have our environment ready. So in our environment as well, we've deployed what is called a config map. So let's say, let me show you the config map, right? So the config map is this one on step 9, the way you have kubectl get config map. So if you just actually copy that script, okay? So I want to show you what is in your config map. And then paste that, and then enter. So what is in your config map is we've actually declared that policy. So this is how you push in your policy into your namespace, right? So we've had the same policy where Alice and Bob that we were going through in the rego playground. This is exactly the same thing, but we just created it as a config map. You can again declare it as a secret if you like, but in this case it's a config map. And then what we've done is when OPA starts, OPA will look at this and then says, okay, do you define a rego policy for me? Where is it? You define where it is. And when the OPA server starts, it will actually pick up your config map, and then we'll integrate that into your decision logs, right? And any questions so far? Sorry?
The same approach actually we can use to the Volt also.
This one? The config map? Yeah, so the
Not
Yeah.
This approach actually,
Sorry.
this approach actually it can be possible with the Volt also.
Remote?
Volt. I mean, VAULT, Volt.
Okay. Vault.
Yeah.
Yes.
Okay.
Yes.
What's the difference actually?
So the way you do it for Vault is you actually can write a REST call. Opera has a function called HTTP send. So in HTTP send, you just define your secret name, and then the value from that secret will actually be returned. So you can write a function to get that value from your key vault, right?
Okay.
And then you use your definition, your data JSON, to match that and see if that value is true, then you allow.
Okay, I think it's a loosely coupling.
Yes, you can do that as well. So, but you need to write the, the data JSON file and whatever you write.
Okay.
Okay.
Thanks.
All right. So what I'm just showing you guys is how the same policy that we talked about, how we can actually put it in your Kubernetes environment. So now what we're just going to do is, so we've done up to there, we've seen all our pod. So what we're going to do now, before, we're going to do two interesting things, right? But first of all, if you copy step 11, I want you to see if you can access your pods. So you copy step 11, and then run step 11 here. So what this is going to do is you're actually executing in your pod, the container you've got, because we're actually using a jump box, which is a Linux box connecting to our Kubernetes environment. So we need to tunnel into a pod. So that's why we're running kubeexec. So that kubeexec is we want to connect into our pod and then run some commands to see if we can serve our page, right? The product page. So it can be, but since we're not using a UI, so we can just tunnel into our Kubernetes pod and get the information. So if everything works okay, you should get this. You should get simple book app. So this is just a small sample to say, right, you are actually connected now. So what we do next is we're going to get a username called Alice, and then we're going to pass Alice username and password into the header, okay? So we want to make sure that Alice has access to the product page, all right? Anyone have any issues or what?
I didn't get the same result.
Yeah, okay, which one? You didn't get it? Okay, can someone help? So you need to be on step 11. Sorry? Your pods are pending.
What you said?
The pods are always pending.
Really? Let's have a look. Why would you kubectl get?
Yeah, same as me. Yeah, it's running now. It's pending.
Okay.
Oh.
So what's your namespace?
Oh, it's still running. It's running for him now.
It's running, yeah?
Yeah.
No,
So
one is pending.
Just refresh, maybe. Just run kubectl get pods again.
I tried twice now.
yeah, try.
Okay. Try again.
Because sometimes it might be
Run it
latency.
again, just run. No, not that part. Just go back to the page. Yeah, just do get pods again.
What's your thunder?
Because I can check what's going on, or someone can help you
Yeah. the
look through.
product page.
So did you run
Product page.
the two? Let's go back again, and deploy the second time. Okay, you can do the redeploy if you have a problem. So on step 10, if you deploy the first one, installing the book info, this one here. So if you copy everything to the end, okay, you install that, okay. So I can do it again, no problems. It's just you're going to try to terminate my pod and restart my pod. So if I do that, again, no change. So that's what you get if you're doing the second time. And then you copy the second one, the ingress as well. Make sure you copy everything under the ingress. And copy everything under the ingress as well. And then run that. Okay, that's quite strange. Does anybody, is anybody able to? Yours was fine. Okay. So change. That's strange. What is your namespace? Can you see? Let's actually see.
Yeah, so your namespace will be the beginning of your URL. Okay, so this one is prompt-panda.
Prompt.
Yeah.
Okay, let's just have a look quickly. kubectl, via pods, right?
No logs coming from that product page pod. It might be that it's just queued on the cluster.
Yeah, we're all in the same cluster, so it may just be taking that to scale up to everywhere.
Prompt. Oh, okay.
So if you look
PUMP.
they slowly coming up. No,
Pumped. Okay.
Anthony, if you go with the -A, you can see that there's a lot of pods coming up from different namespaces.
Okay.
I would assume that will be a timing issue.
Yeah.
I think it's just taking a while because everything else is coming.
Because there are no logs coming from the pending pods. I would expect they will be queued.
Okay, so let's look at the ones, anyone pending. It shouldn't be much pending. So a lot of them are running though.
It's the product pages that tend to be paid.
Oh, right, maybe the product page. So it's taking 60. This one's right, taking Moving Panda is running, taking. Remember what it does is because of the Envoy proxy injecting through admission controller. So you actually have two pods. One is the Envoy. Two containers. The Envoy will be injected. Yes. Okay. Right. I think we might have. So, Feasible Panda's got an issue with the product page. All right. Let's see who else. It can just be latency and Moving Panda. Moving Panda is not. I mean, so we could be having an issue with resource. Yeah, I think it might be a case of resources because we're looking at quite a number of pods now, and that would definitely slow things down. All right, so I do apologize if anyone is having any issues, but it might take a bit of a while. It should come up for you. So, yeah, it is a resource issue because the script will definitely run regardless. Right. So, for those of us who have access, maybe let's just see it.
Insufficient CPU on the cluster.
Sorry?
Insufficient CPU on the cluster.
Is it? Yeah, no. Yeah, maybe we would have scaled it out a little bit more, but we just start.
We're going to quickly try and make more happen.
Right. I mean, if you actually you only need two pods really. You need the ratings and the product page. So if you got the product page and ratings up, we can complete the demo with that. You know, in your pods, if you actually have those two running, then you're almost good. Because ratings we log into, we tunnel into ratings and execute the commands that we want to run. So, okay, yeah, I think we're just resource limitation. Yeah, I mean, with Kubernetes, you get that a lot anyway, when you run a couple of things and then your CPU is maxed out. All right, okay. we can go on anyway for those of us who, because we can't reboot the cluster. So, but essentially what we've done now is what we're trying to do is we have deployed the pods, and then OPA is running at the back as well. And then what's going to happen is we're now running an application. So that executive command that we ran earlier on is just to show you that the user Alice has access now. So we're going to do something very interesting. And then we want to deny any other person apart from user Alice and user Bob access. We're going to actually wire the full OPA into it. And the way we do that, while the guys are helping out to scale out this thing possibly, we're just going to go on so that we can complete in time. So if you do something else as well, for those of us who've got access, if you do kubectl, these are all Kubernetes commands anyway. You can do autocomplete if you like, but I just like typing everything myself. So kubectl get authorization policy. So in this case, you might do an autocomplete, okay? So we want to look at the authorization policy. You should have something like this, all right? So you should have something like this, labeled whatever your name is, the name of your namespace is, and then -auth, okay? So what we then do is, in the authorization policy, we're going to do something. If you do -o YAML, that command, just add O for output, and then we want to spit it out as a YAML file, right? So what we want to do is just want to look at what's going on behind the scene. And this is where we make some small change to that will wire out or wire in our OPA policy with that application. So if you look at this right now, a couple of things happening. So Istio have, like I said, it's got first-class integration with Envoy proxy, and then Envoy uses a GPRC protocol to communicate using SDS. SDS is the secret discovery service that actually rotates your certificate. So when you want to do a TLS across systems, yeah, or MTLS, right? Yeah, exactly. Or you don't want to do permissive or text type of communication. So Envoy provides you GPRC, which actually makes you have small latency and you can have a small footprint of communication, which is very awesome. So in this particular demo, what we've done is we've actually have something very interesting that we've done. We've created this action called custom. So normally, when you're doing Envoy, if you've ever done Envoy, Envoy has what is called an Envoy filter. It's a very difficult thing to communicate or to define Envoy filter, but we have done using a custom definition, and that custom definitions allow OPA policy engine to define what you do in a custom extension. So what we're going to do finally is we're going to change this label, okay? This label, we just put a fictitious label here, but we're going to put in a new label. The new label is going to be the label of our application that we deployed, okay? So if you go back to, let's go to the steps. Now, we are going to, so the guys are going to help out here, just in case anyone run into issues. So I think let's just jump into step 16, and actually step 16, and then the second one here, which is edit authorization policy. So if you copy that command.
Edit authorization policy.
Yeah. I think I missed out one thing. Before we get to that authorization policy, we want to describe the product page pod, okay? And we want to get the label, because sometimes you might not find the label. You want to grab the label and use that label for your OPA definition. So what we do in that case is, if you go to your pod, kubectl again, get pods, which is a command to just list out the pods in there for you. Now, you can see the name of this pod is called product page. So if you copy the name of your pod like that, right? Just copy it to your clipboard. And then all you do is, again, it's easier you type out this thing so you can get familiar with some of this command, at least get you engaged, really. Just before I go, if anyone has any questions, have you been able to?
I just got his.
Oh, you're using this one? All right, okay. Cool. Okay, so what we're going to do is you can do kubectl, again, describe, okay, pod, and then you just paste in the name of that pod that you have in your clipboard. So what we're doing is we want to describe that pod and copy the label in that pod. So, and enter, you'll see a whole load of stuff there. And then if you scroll up a little bit, just scroll up, and then we want to get the label. So we've got a bunch of containers. Istio container is there, but that's not the one we're looking for. We are actually looking under labels. So if you go here, right? So if you go here, you find app is equal to product page. So if you copy this product page, this is the name of the label for product page, okay? If you copy that into your clipboard, right? So just let me go back again. So just towards the top where you have the name of the pod, the namespace, everything else, service account, and then finally you've got labels. Just copy, you know, you got app is equal to this, just forgo the app is equal, just copy this product page only, right? If you copy that to your clipboard, then you just go back again to the next step, and that is here, what we want to do is, we've got a command here, so we've got this command on step 16, the second one. Now, because you've got something in your clipboard, so if you copy, you'll lose that value. So let's just type it. It's quite easy to type.
Is that a kubectl edit authorization policy?
Yes, exactly. That's what it is. You don't need to put the name of the authorization policy because it's just one. So it's just edit authorization. Just use autocomplete, and then once you click on enter, now what you do is you come in there, and then you scroll down towards the end, and then I don't know the command in your, I think it's Shift I or something.
That's what is coming out on my screen with authorization policy.
Yeah. That's just scroll towards the match labels. So, and then because we want to change the value of that authorization policy, of the app, right? So if you do enter Shift I on your keyboard, just to be able to edit something, right? Because we want to edit this value. So once you delete everything under this one where you have label premium or whatever your namespace is, and then you paste the stuff from your clipboard, the label, that label is product page. So that's how you wire your application to OPA. It's quite simple. You just use the label of your application. OPA is aware of it, and it's just going to communicate with your application, okay? So you're not actually changing your pod. Your pod is constantly running. You're not doing anything, but you're just using the label of the pod. So once you do that, you escape, and then you press your semicolon. You want to save that value, right? So to save it is WQ, and then the bang, all right? To make sure it's, and then once you enter, you get edited, it will save, okay? So if you want to confirm that that is there as well, you can also do get authorization policy again, and then make sure it's, what's going on? Get authorization policy. Couldn't get resource list of metrics, cubes, value, why not? Well, server is loaded here. Authorization policy, but we want to see whether the policy is, yeah, okay, that's fine. So you can do .0.o and then YAML. We just want to see whether the label has changed. So here my label is now product page, okay? So we're matching that label, and mine is product page, right? Is that what you're getting? Are you getting that? product page.
What command did you type again?
Yeah, so the command is the same get authorization policy, but we just want to see whether we can get it. Yeah. So we want to make sure that the product page is the label, right? Okay. So once you've done that, now what you've done is you've now tied in your application that is running on its own. So that application is actually running. You're not making any change to it, but you have an OPA engine running. You have your policy that you have actually defined. Now you're actually injecting that policy into OPA. So OPA will deny or allow anything that you've written in your rego policy to that pod or to that endpoint. So it's an application API or just an endpoint. So we're going to now test that now. Hopefully everything works okay. So if you go back to your steps, so what we're going to do now is we're going to move backward a little bit, okay? And then in this case, we're going to use, let's take step 11, okay? In the step 11, we are assuming that initially when we ran step 11, we got full access, right? Now we are expecting OPA to deny access to anyone who doesn't have the right permission. So when you copy step 11, you copy step 11 here because it doesn't have any value there as a user defined. So if you go back to your playground and then you paste that step 11, all right? Initially we got simple application or something like that, right? So now our expectation is that OPA will deny access to that. So if we enter that, so what you're getting is you're not getting anything back. So OPA, we can look at the logs afterwards and it tells us. So OPA has actually denied access to that application, okay? Now, in order for us to define whether this is running or not, we need to know whether user Alice and user Bob can access this thing, right? Because we said from the policy that we've defined that user Alice can access the product page using the username and password. So now that's what we're going to do. So if you go back again, and then in this case, step 12, I believe, because in step 12, the user is Alice, and Alice has a password, right? So we are assuming that step 12, once you inject your username and password, either basic authorization through the HTTP request, then you should gain access, right? So now, if you just copy that step 12 again, everything from step 12. If the demo gods are kind, then we should get access. So if you copy that, yeah, you can see we got something back, right? So let's see what happened again. So everybody, all right, it actually ran the authorization engine. Let me get back here and copies. Right, it copied a lot more. So step 12 is what we want to copy. Just click on that, copy step 12, and then if you come back here and paste. So yeah, so we're getting so keep CTL ratings that user Alice from error dialing backend units tunnels socket connection reset PM. This is a little bit of issues with the environment, but this should actually be working. Let's try again. So yeah, now I think it's latency now is working. So what that means is user Alice, because Alice is a guest, Alice can access that endpoint. Now there's another endpoint on step, if you go back to step 13, I think, let's look at that. So that's an API endpoint, okay? So the first, step 12 is just a normal endpoint, right? That's the page. Step 13, if you copy that, so normally from a definition of what we've written in our rego policy, we are saying that the user Alice shouldn't have access to the API. Okay? We want to make sure user Alice doesn't have access to API. So if we copy that, and then, because Alice is not admin, so only admins that we want to have to give access to the API. Okay? So if we copy that and paste, again, you'll find out that it's denied access. So Alice doesn't have access. But if you just step back and change that to user Bob, Bob is an admin, because the username and password is the same. We just change that to Bob, B-O-B. It's in the rego policy that we've written earlier on. And then if you enter, Bob has access to API endpoint. So what that means is you've actually written a policy that is outside your pod or outside your deployment. So all you need to do is just get your developer to write whatever they like, okay? And then you've got the power, the control to use OPA to define what access you can give to any user or any resources, right? So the final thing we're just going to do is we're just going to look at the backend briefly. I know we're almost out of time, but this is just going to be, we're looking at the logs. Because all of this, you'll see the result of what we've done in the logs, right? So if you go back and do kubectl, get pods, okay? So in your pods, if you copy this OPA pod, all right? If you copy OPA pod, and then say kubectl, it's good you type along with me because I like typing really. that way I get engaged. So kubectl logs, and then you paste the name of your pod. And one thing you could do is you can pipe, okay? If you pipe, and then grep, all right? Decision. So what we're doing, we just want to filter that to only the decisions because there's a lot of verbose information there, but we want to see what decisions are currently happening at the logs level. So if we do that and enter, oh, come on, connection. It's taking a while. Yeah, it came back now. I think we don't have latency. So if you look at the decisions IDs, now what you need to go in and is you need to go in and to look at this end here, decision log. So for the last thing we did, which is user Bob, okay, decision log is data.issue.org, and we got true. If you go back some steps again, you see decision log when we try user Alice to get to access to an endpoint. Like in this case, this is the endpoint, and you get it false. So this is actually telling you that OPA is taking care of all of that stuff, all right? So that's a little bit of what OPA can do and much more, very much more. You can do stuff with your messaging system. You can write messaging system with your pub subs, publisher subscribers, and OPA can define who has access or what can go into your subscription engine. You can use it with Kafka. You can use it with Terraform to define your blast radius, giving the tag or your TF plan. You just export your TF plan as a JSON file and then write a definition to say, I want only these resources to be deleted by this number of users. So it's just something like Sentinel, right? But OPA actually does more than Sentinel in Terraform. So that's a little bit of a taste of what authorization engine looks like in terms of zero trust. Right. Any questions, anyone, or something that needs clarity so we can talk about it? Yeah. Sorry, can we get the mic to?
Just would you give a quick recap?
Okay. On which side?
On the architecture. So
oh, the architecture.
We have the Istio, right?
Yeah.
We have the OPA installed in one of the pods, and then we have several pods, and then
okay. Yeah, I can do.
The policy is actually configured on the pod level.
Yeah.
So we want to see the whole thing a little bit more in
Right, that's excellent, no problem.
Yeah.
So, I mean, I was, because I didn't want to go too technical, right? So, but let's spend a few minutes getting into the technicalities of it. There's a lot of infrastructure that, we took time to build, right? So let's start with the Istio itself, right? So I'm going to do a lot of command type, just follow me, please, right? So we've defined and deployed Istio. So if we do kubectl get, the kubectl get pods -n istio.system. So Istio, this is the control plane for Istio, okay? So if you enter there, you've got a couple of things there. So in the original architecture that I showed you, just showing you that architecture again. So in here, this is the control plane. So Istio D is the control plane. So in that control plane, done is we've deployed Istio, it's got a control plane, and the data plane for Istio is the proxy. And then I'll show you how the Envoy proxy ties up with your application. So that's first. So what we want to do inside that is, so when you deploy Istio, you get ingress, and then you get egress, and then you get the Istio D, which is your mesh, okay? So if we take the ingress a little bit, so this is where your ingress and your load balancer get configured. So if I take this, and I think kubectl describe this one, put this here and paste that, and then that there.
All the pending pods should be running now.
All the pods should be running now. Okay. All right. Awesome. And just what is he saying? No fun and whatever.
Well, just before you continue, sir, in most deployments of Kubernetes for microservices, there's something that sits on top of Istio. Istio is just a suffix proxy. At that level, there's ingress controllers on top of Istio.
Yeah.
Basically looking at the headers of incoming calls,
Yeah.
incoming requests.
Yeah.
And it basically looks at where Istio clusters.
Yeah.
And just applies that traffic to it.
So
that's probably why it's not seeing the ingress controller.
no, that's fine. We deployed what is called the load balancer, right? I wanted to show you guys the whole Istio deployment, but let's go back a little bit now. So this is our oh, come on, not this one. I'm just gonna change to global logic. I think it's yes maybe. So sign in. Because we've deployed everything on Azure, right? So this is our Kubernetes environment here. And so if you go into Kubernetes and you go into services and ingress. So services and ingress, you got Istio, though I was just trying to explain that. Istio ingress gateway is we've defined that to connect to our load balancer. We use an internal load balancer because it's 10.2240.0.6, right? So we're actually using an internal load balancer that is automatically specified for us, right? And the way we've done it is we set up an annotation in our Istio deployment. So if you look at Istio deployment, the infrastructure, let me see if I can show you guys a little bit of that infrastructure. Infra. Let me go into my, right, not main, I think it's test. Okay, so test, we have infrastructure, right? So here is the Istio YAML file, okay? So this is the Istio deployment. What we've done is just something very generic. If you scroll down to the end part of it, we should have the load balancer. Where do we? No, ingress, sorry. Ingress or YAML. So here it is. So what we've done is here, when you set up this annotation in your service, all right, when you deploy it, we said we want to use Azure Load Balancer. So that automatically spins up the Azure Load Balancer for us. So as you were saying, the traffic comes directly from your load balancer, or you can have it as an application gateway if you like, or API gateway, depending on whatever. And then you can have the backend connecting to your load balancer, and that backend talks to your Istio ingress, right? Make sense? So that's the main, that's how we have it configured. We just set up an annotation to say the load balancer, internal load balancer is true. If you change this to external load balancer, then you have access to directly access. But if you want to contain your subnet within your environment, you just make it internal load balancer and use an application gateway to connect to it. Okay, so that's how the Istio is configured. The other part is readily available. And then the final thing I wanted to show you guys is the service mesh. So if you do kubectl get Istio get config map Istio -n Istio -system, right? And then you spit that out as a YAML file. So here what we've done is we have, because we're using an external provider. So when we deploy OPA, in the OPA deployment, we created a service for OPA, and we exposed port 9191 for OPA, and that is a GPRC port. So what we're doing is we went in back into like you can see, you have several of that for all of the namespaces that you are working on. We have an entry there that, we have an entry that defines that service. Okay, so if you look at here, we've got services OPA.whatever, OPA.welcome, Panda, and then it's reporting on port 9191. This is how OPA and Istio get to talk to each other, because we're using an external provider. Istio has its own internal, authorization engine using Envoy filter, but for now we just want to, I think I've got something on Envoy filter, if I can show you guys there. I think it's in, I don't know, yeah. So this is how Envoy filter looks like. So whatever we've done here, if you want to use Envoy filter directly, you can see that in here, we are defining we're actually going to define port 9191, and then we can write all of those policies directly and push that into this Envoy filter. You have to write this Envoy filter, and you have to write this Google GPRC. You're doing everything into Envoy, but we took that away from Envoy, and when we gave the power to provide that provision, that external authorizer to OPA using the GPRC. So that is much cleaner and much safer, because you don't need to worry so much about configuring your Envoy filter directly. So Envoy filter is native to Envoy, but OPA is sitting on its own separately. So we kind of deployed it away from there to make it easier to manage. Sorry, does that answer most of your question? Awesome.
A lot of organizations will have their Envoy filter already. Right?
Yeah.
And if you have multiple layers and you have OPA independent,
Yeah.
it might needs a little bit of a, let's say, persuasion or to showcase the benefits.
Of this one?
Yeah.
Oh yeah, I know. But I mean, trust me, if they use it, they will get the benefit, and that's what we use in the companies I work with. Because Envoy filter, actually, the problem with Envoy filter is you will actually need to write, if you want to filter traffic on Envoy, you need to write something for this HTTP connection manager, and that is an additional plugin. And when you write the connection manager, you then write a function to filter your value, because you're using HTTP coming from the filter, the Envoy filter, you're putting everything in there and you're writing it in the code inline. That's not good. So, but what we've done is we're using the custom authorization policy method and taking all of that stuff from Envoy filter. So OPA sits on its own. You can actually have OPA as a sidecar container, but we moved away sidecar container. We run OPA again as a sidecar, but we're running it separately as an instance in your namespace. And the advantage of that is if OPA goes down, your system still run, right? Or something happens, the OPA still control so many other stuff. So you can have one OPA controlling all your environment, if you like, using several what I call bundle servers. Again, that is outside the scope, but there is so much around it that when you start digging into it, it's so intuitive and so powerful to use, you know.
Can you use, just like the way you use mash label, when you're specifying the pods that will connect to OPA, can you use, just like the way you do in Kubernetes network policy, can you use maybe something like namespace or maybe IP to connect the pods?
Okay, so if you in Kubernetes, right, when you actually want to connect, do something across a pod. Yeah, so when you want to do something across a pod running, so your network policy is a CNI. Your CNI is actually sitting on top of the Kubernetes environment. It's part of the Kubernetes infrastructure. So now you want to move away from anything Kubernetes CNI or Calico or whatever it is that you're doing, right? So what you want to do is you deploy something there, and that stuff runs on its own without any interaction with the infrastructure or layer of Kubernetes, and just run something else that would talk to your application. So this is actually application talking to OPA rather than you talking to rather than you talking to attribute-based control. So for what you're talking about, you can do attribute-based access control, and then in that attribute-based access control, you can then define, I want the range of IP addresses. Okay, so that is attribute-based access control. But we're doing role-based. Role is user, ID token, and access permission. So which is more like user comes in from your network, you want to know who is coming in, who is accessing, you want to grant people access based on the roles that you've actually defined. So there are two separate things. In this case where you're talking about, you've got Gatekeeper, which is also a policy, OPA policy engine on its own that runs on Kubernetes, but you can define Gatekeeper to do that attribute-based access control, right? But we're doing something extremely different, which is we're working with developers, right? Because developer, you don't want to get them to do all that writing of access control for you. You want to do it yourself as an infrastructure guy, and that gives you the power to, you know, define how many people or how you can dynamically change those accesses, right? Okay. Any more questions, or that's all? No more. Okay. If no more questions, thank you, everyone. I hope you enjoyed the session.